All right, let's talk about something that's literally running our world, even when we don't see it: algorithms. They're the secret sauce behind everything from your Google searches to your Netflix recommendations. And honestly, if you want to understand our modern world, you've got to understand algorithms. But that brings up a really interesting question, right? Computers today are unbelievably fast. I mean, they're lightning quick. So why on earth do tech companies spend so much time and money obsessing over making their algorithms just a tiny, tiny bit faster? It seems kind of strange, but as you're about to see, those tiny improvements, well, they change everything. Okay, so to really get to the bottom of this, we've got to start at square one. What exactly is an algorithm? Forget all the complicated code for a second. The core idea is actually super simple and has been around for thousands of years. Yep, that's pretty much it. An algorithm is just a recipe. It's a list of steps you follow to get something done. You start with some ingredients, that's your input, and you follow the steps to get to a final result, like a cake. It's just a plan. You're using algorithms all the time without even realizing it. The simple act of getting to the gym, that's an algorithm. You follow a specific sequence to hit your goal. And just like with cooking, there can be a bunch of different recipes or algorithms to get the same job done. It's just that some are way, way better than others. So, to really see what I mean, let's try a little thought experiment. This is where you'll see why the design of an algorithm is so incredibly important. Imagine I hand you a book. It's 696 pages long, and I tell you, find page 100. How would you do it? Seriously, think about it. The method you choose, well, that's your algorithm. Let's look at two totally different ways you could tackle this. First up, let's look at the most obvious, almost ridiculously simple method. We'll call it the naive approach. You don't need to be clever to do this, but it will get the job done, eventually. The plan is super simple. You just check every single page one by one, right from the beginning. You open to page 1. Is this 100? Nope. Okay, next. Page 2. Is this 100? Still no. Next. You just keep grinding through page after page until you finally hit page 100. It works, for sure, but you can just feel how inefficient it is. There's a funny thing about computer scientists. They're professional pessimists. When they look at an algorithm, they always focus on the absolute worst-case scenario. For this method, the worst thing that could happen is if we were looking for the very last page, page 696. That would mean we'd have to make 696 separate checks. So this method has a name. It's called a linear search. And in the programming world, we describe its speed as O of n, or big O of n. Big O is just a fancy way of talking about how much longer an algorithm takes as you give it more stuff to work with. Here, n is just the number of pages. So O of n simply means the time it takes is directly tied to the number of pages. If you double the number of pages in the book, you double the maximum time it'll take to find what you're looking for. It's simple, but it's slow. Okay, but nobody would actually do that, right? Come on. We'd use our intuition. There's got to be a smarter way. And of course, there is. It's a classic strategy in computer science, and it's called divide and conquer. Instead of starting at page 1, you just, bam, open the book right to the middle. Let's say that's around page 336. Now you just ask one simple question. Is the page I want, page 100, higher or lower than 336? Well, it's lower. And here's the magic trick. You now know you can completely ignore the entire second half of the book. It's gone. In one single step, you've cut the problem in half. Then you just do it again with the half that's left. And this right here, this is the whole game. Every single time you make a check, you're not just getting rid of one page. You're getting rid of half of all the remaining pages. The problem shrinks incredibly fast. This brilliant method is called a binary search. Its efficiency is described as O log n, or logarithmic time. Now, don't let the name scare you. It basically means that the time it takes to run grows much, much slower than the size of the problem. Think about it. If you double the size of the book from 700 pages to 1,400 pages, this amazing algorithm only takes one extra step to find the answer. It's just insanely efficient. So let's put these two head to head. The slow path, linear search, just plods along checking every single thing. The smarter path, binary search, keeps chopping the problem in half. O of n versus O log n. One is slow and doesn't scale well at all, while the other is wicked fast and scales beautifully. This is the big aha moment when it comes to algorithms. Okay, so a few hundred steps versus maybe 10 steps. For one book, who really cares, right? But remember the question we started with? This is where it all clicks into place. This difference doesn't matter for one book. It matters when you're dealing with data on the scale of, say, the entire internet. The companies that run our digital lives, Google, Amazon, Netflix, you name it, they're not searching through a 700-page book. They are sifting through billions and billions of items. And when you're working at that scale, your choice of algorithm isn't just a small tweak. It's the difference between something being possible and being literally impossible. And just look at this chart. I mean, wow, it says it all. To find one thing in a sorted list of a billion items, a linear search could take, in the worst case, a billion steps. A binary search? It would take about 30. That's not a small difference. It's an astronomical, mind-blowing difference. A billion steps versus 30. And this is the real-world impact we're talking about. Choosing a smarter algorithm can be way more powerful than waiting a decade for computer hardware to get faster. It can take a problem that would literally take months to solve and make it finish in the blink of an eye. And that right there is exactly why big tech companies are so obsessed with this stuff in their interviews. They're not asking these brain teasers to trick you. They ask because their entire business model is built on solving enormous problems efficiently. They need people who can think this way, who can build solutions that work at a ridiculous scale. So let's boil it all down. What's the key takeaway? First, an algorithm is just a recipe. Second, how you design that recipe matters more than anything. A smarter algorithm isn't just a little faster, it's in a completely different universe when you're dealing with lots of data. And finally, this incredible efficiency is the engine that powers our entire modern world. And that kind of leaves us with one last thought. This isn't just about computers and code. This idea of finding a more efficient algorithm to solve a problem is a really powerful way to think about things. Now that you see the difference between a brute force approach and an intelligent one, what if you could apply that kind of thinking to the challenges in your own life?